Hello everyone, welcome to this Node-RED tutorial. My name is Sandeep and today I'll be guiding you through a Node-RED flow that demonstrates some basic operations including injecting messages, splitting and joining data and perform calculations. Let's get started. So coming to the section 1 basics, inject node sends a timestamp as a payload with additional properties, topic set to my topic and test property with the value hello world. The debug node displays the complete messages object in the slide bar including the timestamp payload, topic and test property. Section 2. The delayed debug. The inject node sends a timestamp as its payload. The debug nodes display only the payload as a timestamp and the delay node basically introduce 5 seconds delay before passing the message along. The debug node displays the payload again after the delay of 5 seconds, demonstrating time control in the message flow. Section 3. Splitting and join. The inject node sends a JSON array of objects with property OP1 and OP2. The split node splits the array into individual objects. The debug node displays each split object. The change node basically calculates the sum. It calculates the sum of OP1 and OP2 for each objects. The change node basically it calculates the product of OP1 and OP2 for each object. The join node combines the process messages back into a single message. Finally, the debug node. This displays the combined messages with calculated sum and products. Section 4. Object processing. The inject node sends a JSON object with temperature and humidity values. Split nodes basically splits the object into individual messages for each properties. The debug node displays the individual properties, the temperature and humidity. The switch node routes messages based on the value of the topic property. Finally, the debug nodes displays messages based on the topic, a temperature and a humidity, showcasing message routing based on property values. Before proceeding to the further steps, I just want you to subscribe and leave a comment below. It basically motivates me to create more and interesting content. So let's proceed further to the next step. Section 5. Function nodes. The function nodes initialize a variable myData with the test objects and returns it. Inject node injects an empty payload to trigger the function node. The debug node displays the output of the function node in the debug slider. Section 6. The condition logic. The inject node injects a message with the topic new data to trigger the flow. Another inject node injects a message with a topic update to trigger the flow. The function node sets the message topic and sets node status accordingly. The debug node displays the messages based on the topics which is received, that is new data or updated data. Section 7. Warn and log. Function node issues a warning messages using a node on warn. The debug node displays the warning message in the debug sidebar. So section 8. Async output. Here enters the async output function node. This node is a powerhouse for dynamically sending messages based on real-time conditions. Here is the below code. So basically explanation of this is here we can check if the incoming payload is divisible by 2. If it is true, it sends a new message with a topic set to hey and payload as even. Section 9. Multiple message outputs. The function node sends message with different payloads based on the conditions. The debug node displays messages based on the condition even or odd payload. Section 10. The multiple ports. Function node routes messages to different outputs based on the payload value 1, 2 or 3. The debug nodes display messages routed to different outputs in the debugger sidebar. Through this demonstration, you have learned techniques for using function nodes to initialize data and processing messages based on specific conditions. The versatility of noded is routing messages to different outputs based on payload values and topic conditions. Practical example of warning messages and logging within functions node for debugging purposes empower you to create complex and efficient automation flows.